Hello everybody. Today we're going to be going over a trigonometry problem at the IB Math Studies level. So the problem gives us, this triangle right here, points A, P. They give the sides 40 for the line AB, the distance 30 for the line PB, and the angle 48, right? And so for part A, it asks us to draw and label with an X the angle of depression of B from P, okay? Now, I always used to confuse the angle of depression and elevation, okay? And what I suggest is drawing a horizontal line. So, for the angle of depression of B from point P, since it's from point P, I'm going to draw a little horizontal line right here, okay? And from depression, it's always going to be looking, you start looking straight ahead and then down, okay? So then straight ahead on the horizontal line and then down until I reach like looking at point B, which would be right here, and so that's angle X, okay? If I were to talk about the angle of elevation of P from point B, it's also going to be a horizontal line, but instead of looking down, we're going to be looking up, okay? So we look up until we're looking directly at point P, which would be right here, okay? That was just to show the difference between angle of depression and angle of elevation, okay? So part A is done. Part B, they also tell us that angle APB is acute. Okay, this one is acute. If it's acute, it means then that this value right here is going to be, let's call it y degrees. Y degrees is going to be less than 90. Okay, that is acute. If it were greater than 90, it would be obtuse. Okay, and if it's equal to 90, it would be a right angle. Okay, so in this scenario, it's going to be less than 90. And it asks us to find the size of the angle APB. Okay, so here we have one angle and we have two sides, okay? So we immediately have to think, does my angle match one of my sides? And when I say match, it has to do with the sine rule, okay? The sine rule says that if we have little a over sine of big A, it will always be equal to little b over sine of big B, okay? Little is going to be distance and big is going to be angle. So we have that for the angle 48. Its pair is going to be the distance 30. And for the distance 40, its pair is going to be the angle we're looking for, right? APB, which I denominated y. It's going to be equal to sine of y degrees, okay? And here we have to cross multiply, so we have 30 times sine of y is equal to 40 times sine 48, okay? We want to leave y alone, so we have sine y is equal to 40 times sine 48 divided by 30, right? And if we work this on the calculator, we get, okay, and if we put that whole chunk into the calculator, we're going to end up with sine y being equal to 0.99085, okay? We're not done yet because y is still not alone. So luckily in our calculators we have sine inverse. So we use sine inverse here and sine inverse on the other side. These sinuses, I guess we could call it, are going to cancel out. We end up with y being equal to sine inverse of 0.99085. This will give us that y is equal to 82.24 degrees. So that is part B, the angle of APB. Okay, and for part C, we have to find the size of the angle of depression of B from P, which is the value of x that we defined in part A. So with parallel lines, which are the ones that we have right here, the dotted one here and the dotted one there, if you have parallel lines and they are being cut by, well, anything, any line in between. There's a property that forms, okay? This value is equal to this value. This angle is equal to this angle, okay? And these are also the same, okay? So if this is, I don't know, A, this is also A, this is also angle A, angle A. If this is B, this is also B, this is B, this is B, okay? So now that we have that visualized, we can use that property right here, okay? That being said, this value of x right here is the same value of x, only hidden here, okay? And the way to see that is with the parallel lines that we drew before, okay? So, since we only have one missing angle of the triangle, we can do 180 degrees minus 48 degrees, this one, minus 82.24 degrees, which is this one, should equal x degrees, okay? And x degrees is going to be 49.8. So that is part C. However, I feel like it's super hard to notice the parallel lines thing, so I'm going to show it another way. Another way to do it would be to imagine a right triangle here, okay? This right triangle right there, okay? And since we forced the right triangle, we know that this is 90 degrees, okay? We can get this value the same way as I just showed, right? Doing 180 minus 48 minus blah, blah, blah. And we're going to get 49.8, okay? You can do this without having the knowledge of the parallel lines. You can get up to this part, okay? We can also find this angle right there, okay? I'm going to call it Z. And since this is also a right triangle here, visually speaking, we can have that the angle Z is going to be 90 degrees minus 49.8. Okay. We end up with angle Z being 40.2, okay? And so now, bring this triangle over here to make it more visually appealing. We have the right angle there. We have the 40.2 we found before, and the angle X we're looking for. Okay? And so to get the value of X, again, as before, we're going to have 180 degrees minus 90 degrees minus 40.2 degrees. It's going to equal X degrees. Okay? And if we work this out, we're going to end up with X being 49.8. Okay? The same answer we got before. I'm just, again, showing a different way because I feel like it's hard to visualize the parallel lines. Okay? But yeah, there's the answer. I hope it helped. And it's very important to note that the sine rule is always going to work in pairs. So get familiar with that. I hope it helped.